Flood fill. We are given a 2D grid or image where each cell has a color represented by an integer. We're given a starting position, SRSC, which is basically the coordinates for the grid, and a new color or integer that we want to replace the starting color with. Let's try and understand this problem. Basically, given a starting position, the problem wants us to check its adjacent cells. If any of the adjacent cells have the same color integer value, we recolor it to the new color integer value. Right off the bat, this is a classic graph or grid traversal problem, and in any spread out or explore adjacent cells scenario, BFS and DFS are usually used. I will use DFS and a recursive stack in my solution because it's more straightforward. First, we want to find what the original color integer value is by accessing the image grid cell corresponding to the given SRSC coordinates. Then, if the original color we want to fill is the same as the new color we want to fill it with, obviously nothing changes and we just return. Like I said, we want to use recursion to check and update adjacent grid cells appropriately. So we would need a helper function that can do that for us. After this recursion has finished, we can return image. If you're wondering why we have to create a helper function for recursion, it's because our main function doesn't necessarily have all the information for recursion. And the problem isn't as straightforward like a factorial recursion problem, for example. For this problem, we need the original color of the starting pixel, and the main function does not include that as part of the input, so we pass it via a helper. Let's create the recursive function called dfsfill that takes in the same parameters with an additional original color parameter. We first want to ensure we are accessing valid grid cells, so if either the SR or SC coordinates exceed the boundaries given by the grid dimensions, we can just return. Also, if this pixel we are on isn't the original color, then we can just ignore it. Otherwise, we can update the color to the new color, then we explore our adjacent neighbors, which means we check the cells to the left, right, above, and below our current cell. Now, all we have to do is to call the recursive helper function in our main function, and we're done. The time complexity is O of n, where n is the total number of pixels in the image, and in the worst case, we might visit all the pixels once, by pixels meaning row by column. Space complexity is O of n, in the worst case due to recursion stack.